Hello everyone, welcome to Java Expert. Today we will discuss about microservices architecture with Springboot. So this is going to be a series of videos where we are going to have all theoretical things as well as practical things. In the first session, we will learn all theoretical steps, and in the upcoming videos we will do all practical steps also. Alright, let's begin. Before discussing about what is microservice and all, we have to understand what is monolithic architecture it is. Monolithic architecture is the one where we were using for a long time. So today we briefly discuss about what it is, right? What is monolithic architecture? Monolithic architecture is a unified development model for software applications. We all know that in monolithic architecture we will have one package, is a var or er file, which will have all our application related components. Majorly we can classify into three parts: client side user interface, server side application, and data interface. When you are referring client side user interface, it can be HTML, JSP, or CSS, JS files. Those things will be there. When you are referring to server side application, mainly it will be done in a Java, right? Java object class files will be there, which will be running on the server. And the third one is data interface. It will those are the components which will use to connect with the database, right? Now all those things will be packaged in a single var or er file, and that file will be deployed in the container, right? JBoss or Tomcat or WebSphere. So those kind of application will be used to deploy this package var or er file, and that's how monolithic architecture works. Fine. I hope you understood what monolithic architecture is. Now we'll move on. What are the challenges we have with the monolithic architecture? You have to understand this, no? Fine. So these are the challenges. Mainly we have tightly coupled between components. We have one common package, right? We have var or er file, right? So if we want to scale up any one particular module, right, we may have admin module, we may have a payments module, we may have accounts module, right? We have a lot of transactions, so we want to scale up only the transaction module, which is not possible with the monolithic architecture because everything is tightly coupled, it packaged in a single file, right? Then large code base. Fine. Since the entire application, the application is very huge, so the code base also will be very huge. We have to maintain it, right? Scalability of specific component. As I already said, everything packaged in a single file, so scaling up one particular component is not possible. Development slowness. So each build, even if you're going for a small change in a particular component, we have to rebuild the entire application. So that will lead to this development slowness. Testing of entire application. Even we have a very small change in a report or a minor bug, we may go for a fix. In those cases also, we have to do entire application regression testing, right? Tightly coupled with technology. What it means, like, see, today we have a Java technology, so we have started application with developing using the Java technology. Later on, we may find new technology where it will be even more useful, even more easier. But since our application we started with Java, adapting a new technology into the existing monolithic architecture is not that much easy, right? It will be a challenge for us. Problem with deployment and downtime in production, right? Even if we go for a minor fix, small change in the report, we have to deploy the entire application that time. So we have to deploy the application, we have to restart the service. That will lead to the production downtime, right? So these are the major challenges we have with monolithic architecture. Fine, let's move on. Now we're coming to the main picture, microservices. Before getting into the microservices, one thing I want to clarify you all, that I have seen many resumes when I'm going for an interview, right? I have seen many resumes where people will use to mention that microservice as a programming skill. In the programming section skill, they have used to Java, mention like Java, Springboot, and in that line they will mention microservices also. You have to also to understand microservice is not a programming skill, it is a architectural style, right? What are microservices? Microservices, also known as microservice architecture, is an architectural style that structures an application as a collection of services, right? Basically, when you go for a microservices architecture, you will be breaking your major big application into a small services, right? You can refer this diagram here, like, there's a big application, so that is being broke into the 5 different services. Each service will work independently, will run independently, we can deploy independently, it will do that particular task alone, right? For example, we have a major application, we can take, internet banking. We may have accounts, we may have payments, we may have some utility payments, we may have admin module, right? So this and all these components, all this module can be developed independently, separately, as a separate service, and can be deployed independently. That's how this microservices works. Fine, we will move on and we will discuss in detail. You can able to relate it if we continue with in the next slides and all. Fine, let's move on. Okay, I hope you understood, at least know what is microservice it is, right? Now we will see what are the advantages we have with microservices. Highly maintainable and testable. When I say highly maintainable, see, this entire code base will be very small, because we have broke your big application into small things, right? So the code base will be very small, and we have to maintain each our code base separately, independently, and it's going to be tested independently, right? And loosely coupled, right? Our entire application will be broken into small pieces, right? If you want to scale up only the accounts module, if you want to scale up only the transaction module, which we can easily do that, because each service is running independently, so we can scale up only for those modules based on the need, right? Independently deployable. Fine, so easily relatable, you can easily understand this one. Since we have a separate service, independent code base, we can independently deploy that. Independently scalable, as I already said. Won't be a small team, because each service is going to be a small code base. It's going to be perform only one particular task, and it can be maintained by small team. Smaller code base, I already said. Programming language independent. The one of the major advantages, our applications are already running with multiple services, so we have advantage to develop our services with different languages. Microservices 1 can be developed with Java, microservices 2 can be developed with some different languages. In future, if you found any new language that's going to be useful for you, you can select that language and you can use it to develop your new services. So that is advantages we are having with microservices architecture, right? I hope you understand what are the advantages we have with microservices architecture. So next we will move on to what are the challenges we have, right? Even everybody is moving towards the microservice architecture, there are disadvantages also, right? In the upcoming videos we will see how these disadvantages are getting addressed, but now we'll discuss what all are the disadvantages we have with microservices. Communication between services. Even though we broke our services into small services, right? Our application into small services, but each service is dedicated to one particular job alone, right? But sometimes that job alone, the particular service alone, cannot fulfill the business need, the client need, right? So what will happen is, when client is requesting a particular service, that service needs to communicate with some other services, so that the client requirement can be satisfied. So each service needs to communicate with each other, right? In the monolithic architecture, that's not the case, because everything is packaged in a single file, right? Next, debugging become more challenging with microservices. Since we have many services, if something went wrong, to identifying the root cause, where the request went, where it got failed, so those things becoming very challenging in the microservice architecture. Next, difficult to manage a large number of services, right? If you have a 5 or 10 services, yeah, it can be manageable, but if the number of services grow on over the period of time, if it is goes 50 or 100 services, it will be difficult to manage all those services, right? Integration testing is not easier. What it means actually, see, each service is independently deployable, it is running independently, but if you want to replicate the production scenario, you should have all the services up and running so that you will get a proper response. So when you go for integration testing, even if you're going to test one service, to get the production equivalent response, you should have other services also, right? Infrastructure cost may be higher with microservices, right? If you compare with monolithic architecture, in monolithic architecture we are having one package var or AR file, so it's going to be deployed in one server, right? But in case of microservices, we will be having many services for the same application, so we need a many servers, right? And we'll be going to see some of the design patterns and this one sample microservices architecture, where you will see that there are other components, other services also required, where that is also need of the infrastructure, additional infrastructure. Fine. So these are the major disadvantages we have with microservices, but there are tools to address these disadvantages, which will be we'll talk later. Microservices design pattern. So before getting into any design, if you are going to design application, you should be aware of this design patterns first, right? These are the kind of guidelines where you have to aware of it. Based on these design patterns only, you need to design your application, right? Before getting to the design patterns, there's one more information I want to convey you guys. If you are going to design an application using microservices pattern, microservices architecture, think twice, is this microservice design patterns is really required for your application, right? Because microservice design architecture have its own advantages as well as disadvantages, right? Before designing any application, you list down the business requirement, what are all the current business pain areas, the challenges which they are facing it. If we are going to implement the same application with the microservice architecture, are these challenges, pain points is going to be addressed? If yes, you can. Otherwise, no meaning of implementing using microservice architecture, which will cost you in another way, right? Fine. Microservices design pattern. So I just mentioned most important design patterns here: API gateway design pattern, aggregator pattern, circuit breaker pattern, chain of responsibility pattern, asynchronous messaging design pattern, database or SAR data pattern, command query responsibilities aggregator design pattern, normally called as CQRS, right? We will see one by one in detail. First one, API gateway design pattern. See, we are having many services for application. So when client trying to call you for a service 1 or 2 or 3 or 4, they cannot remember all your IP address, port, all those stuff, right? Earlier in monolithic architecture, we have only one server that is easy to remember by the client. Now we have many things, right? So this is the case. We need a gateway where your client will call gateway, and there are certain configuration we will be having in the gateway server. That gateway server will forward your request to the corresponding microservices, right? So by seeing this diagram, you can easily able to understand what is API gateway pattern is, right? Fine. Next, aggregator pattern. As I already said, each service is running it's for one particular task, which does not mean that that particular service alone can fulfill the business need, right? So if you see this diagram here, service 1 is getting invoked, but to fulfill the business requirement client need, service 1 need to call service 2 and service 3, right? Service 1 invoke service 2 and service 1 invoke service 3, get the response from both the services, and aggregate the response, and it will send back to the client. This is called aggregator pattern. All right. Next one, circuit breaker pattern. Right. What is circuit breaker basically? If there are two states in that you can relate with electrical term also, electrical electronics terms also. If circuit is open, which means that connection is basically it is disconnected. If circuit is closed, the connection is established, right? How it works in microservice architecture here. See, client is calling service 1. Service 1 needs to call service 2 to fulfill the client need. Okay, but for some certain reason, service 2 is not responding properly. Okay, what service 1 will do is, when you are enabling the circuit breaker pattern, service 1 give the request to service 2. It will try 2-3 times. That's everything is based on the configuration only. It will try 2-3 times. If we are not getting any proper response from service 2, what service 1 will do is, it will open the circuit, which means the connection will be removed, disconnected from the service 1 to service 2. So there's a fallback method will be there in service 1, which means if service 2 is not responding, what should be the response we have to give to client? That is already written. So what will happen when service 2 is not available? It will give the default response what is written in the fallback method, and it will open the connection, open the circuit basically, right? And it will wait for, it won't give the further request certain period of time, that is also configurable in the configuration. It won't give any request to service 2 until the service 2 is getting recovered. It can be by own, or there are manual interventions required to bring service 2 back, right? Then after that period of the break time, service 1 again try to test the service 2. You give another 2-3 requests. If you are getting proper response, yes, the circuit will be closed, then it back to normal state. Now also if you are getting the same error, or again service 2 is not responding, again the circuit will be open, and it will be, the connection will be removed, it will be disconnected, right? So this is called circuit breaker pattern. I hope you understand. We will do all those things in practical in the upcoming videos. So stay with me. I'll give you all the practical cases. We'll be implementing using the Springboot practically. Believe me, we will be doing everything in practical in the upcoming videos, right? We'll move on. Chain of responsibility pattern, right? Again, in this case, you see the diagram, right? Client to gateway is invoking service 1. Now service 1 will invoke service 2, service 2 will invoke service 3, and the response will come back in the same flow, and the response will send to client. It will be it's a kind of a chain of responsibility. You see the diagram, right? 1 to 2, 2 to 3. So it's simple, right? That's called chain of responsibility pattern. Next, asynchronous messaging design pattern. The name tells that it's a asynchronous call, right? So when I say a client is calling gateway to service 1, now service 1 want to call service 2. Whatever we have seen earlier diagram is a synchronous call. Service 1 will call service 2, it will get the response immediately, and the response sent back to the client. In case of asynchronous messaging design pattern, it will not be a direct REST call, or it is not a synchronous call, right? In between we will have a message broker, right? Service 1 put it request to a queue, and service 2 listen it through the message broker. It will receive the message, it will process it, and it will put it in another queue. Service 1 listen that queue and will get the response and send to the client, right? It's a it's a asynchronous call. It is we already known term it, this one, right? Yeah. We'll move on to next. Database or shared database pattern. There are guidelines in the microservices pattern, like each service should have its own database, right? There are challenges practically also. Now we have small tasks as a services. Is it really required to have a separate database for each services? There are many cases in the real-time practical cases also. All the banks, many of the banks who they are following this microservices patterns, they are following the common database for all the services. right? It's all based on the need. Really, if you need a separate database for each services, we can. Or you can think that if it is not required, fine. You can have a common database for all your services. The database or shared database pattern means, like, if you see the diagram, service 1 need a separate database for its own. Yeah, we have a separate database for that. Service 2 and 3, okay, these two services can a common database. We have a common database for service 2 and 3. So these all are based on the services and its nature, where we no need to duplicate the data between the services. We no need to maintain the same data in different databases. Based on that, we can group the services. We can keep a common database. So that is called database or shared data pattern. Got it right? We'll move to next one. Command query responsibilities aggregator, CQRS design pattern. It looks like some difficult to implement it, but in monolithic architecture also we have this one. They might have some different terms getting used over there, but the purposes remain same. I just explain you in monolithic architecture how we have is like, we have a transaction system, we have a transaction database. Whatever the transaction the user is performing, everything will be stored in the transaction database, and periodically those data will be pushed to or pulled to some other database for reporting purpose. You got it? If somebody is, if you guys are working in real-time project with any bank or somewhere, you can able to relate this, right? All the data, whatever we are storing in the transaction database, that will push to other database for reporting, right? Here also we are doing the same thing, but the implementation is little different, right? We have separating this database into two, command and query. When I say command, all these transactions, insert, update, delete, everything will happen using that command services. When I say query, it's for report. We are going to only retrieve the data from the database, right? Okay, now if you see the diagram, we have two clients. One is a command client, right? Command clients, they may be doing the transaction. Basically, they are initiating something to insert or update or delete in the database. So give the request is go to command 1 service or 2 service, we perform the operation, inserting into database or update or delete, and it will create an event. When I say create an event, just now we see that asynchronous messaging, right? You're getting me, right? So it will insert or update into the database, transaction database, and it will push copy of the message into a queue, right? Normally we call it as a event. It will create event, which means it will put it in a queue, right? Then there is one more service called event handler, right? It will listen the event, it will get the event, and it will process and insert into the report database, right? So whatever is getting updated in the transaction database, now we have in report database as well. It is not necessary that it should be the exact format of DB or database or table in transaction should be in the report also, because transaction database is specifically maintained to faster entrance, faster processing, right? We have to process the transaction faster. When you come to the data, when you are coming to the report, this also should be fast, but the reporting format will be different, right? It is not same as how we are inserting in the database. It may be a different one. So when we are processing the event through the event handler to the reporting DB, where we can customize it. Customizing means it can be the different data format. We can be storing in the report database. And there is a report client. We will be initiating a request for a report. We'll go to gateway, go to query service. This will connect to the report database and it will retrieve the report for the report client. Getting me, guys? Got it? Fine. It's a simple thing. This diagram looks some kind of what it may feel like some difficult in this, but it is not. It is very simple thing. Yeah, fine. I think we have covered major design pattern with the microservices. The theoretical things, just keep it with you. You can easily relate this with the real-time things, and when we're implementing in the practical, you feel awesome on that. Yeah, we'll move on next. Springboot, right? What is Springboot? Springboot is an open source Java based framework. You keep it in there is another framework, Java based framework. That's it. It provides Java developers with the platform to get started with an auto configurable production grade Spring application. Here one thing we have to understand is auto configurable, what it is actually. If you take any other Java based framework, you have to do a lot of configuration, right? I think you will agree with me. If you take a Struts or Spring, any other framework, you have to do a lot of XML configuration to make your application ready for the production, right? But in Spring Boot, there is no configuration at all, right? Everything will be auto configured by its own for you, right? So that is the beauty of Spring Boot. Now the next question is, so why this microservices always needs to be implemented in Spring Boot? It can be implemented with any other technology. It is not only for microservices, not only for Spring Boot, right? But why they are now preferring to implement the microservices with Spring Boot, right? Spring Boot is a framework to develop such microservices very quickly because it offers a convention-based programming paradigm instead of configuration-based programming, right? There is no configuration. There's completely zero configuration, guys. You have to believe me, it's completely zero configurations. Only everything driven using annotations. Very simple annotations you have to put somewhere on the class level or method level. That's it. Your application is ready, right? So that is the reason everyone is preferring Spring Boot framework for the microservices. Understood, right? Fine, we'll move on. Just look at this diagram. It's a very simple one, architecture using microservices pattern. That's it, guys. We are not used many patterns here. We used a gateway here. Client is there. We are used to gateway, and there are 4 different services, right? We have fund transfer, we have accounts, we have reports, we have utility payments. These are the 4 services we are going to have. And client will invoke the client. Client will invoke the gateway. Gateway will route to our downstream microservices based on the configuration. I will explain how we have to configure gateway, right? Fine. And if you ask me, this is production grade architecture? No, because see, you have to look at where is security, right? Where is logging? How to aggregate the log? We have 4 services. How to aggregate the log? Where is some monitoring, right? There are other services we have to use. Registry services. Those all are the primary things, mandatory things we have to use to make our application as production ready. Got it? Yep. So initially we will be developing this design first. We will develop this one. We will develop fund transfer, we will develop accounts, we will develop reports, we will develop utility payments. All these services separately will run independently. We will develop gateway and we will initiate the request. We will go to gateway. We will see how these things works, and we will enhance with the registry service. We will enhance with security. We will enhance with logging, enhance with monitoring. We will make it production grade application, right? Stay with me, guys. So here what we have to do is, on the next session we are going to implement everything in practical. So you need, in your system, Java 1.8 needs to be installed. You need any one Java based IDE, preferably Eclipse. It will be good. If you have a Spring tool so it is specifically designed for Spring based application, if you have, that's also good. IntelliJ, that is also you can use. I believe it's a licensed one. It's not for, it's an enterprise one. We have a community version, but I do not have a complete feature. So that's up to you guys. It should be some Java based IDE. That's it. Then keep installed Postman to test your microservices, right? So before coming to the next session, there are few things you have to do is you should have a basic knowledge of Java. That is mandatory. So on the next session we are going to implement everything practically using the Spring Boot. And the Spring Boot, the technical things, we have seen some theoretical things around the Spring Boot, right? Because it's a very easy. If you have a basic of Java, Spring Boot is nothing. You can easily learn it. The only thing you have to learn in the Spring Boot is the annotations, where we have to use, what this annotation is doing, how it works, right? So those things we will learn on the practical session itself, right? It looks like a plain Java code. On the plain Java code, here and there we will be placing some annotations. Yes, that's it. than our application ready. Believe me guys, on the first run, your production ready application will be up and running. You cannot imagine that in the monolithic architecture, you configure application, you build the application, your var or VR file is ready, and you are placing it into the application server or JBoss, Tomcat. Do you believe that it will run in the first attempt? Never know. But believe me, and Spring Boot, you can make it happen in the first attempt itself. Okay guys, we will see on the next session with the practical examples. Stay with me. Bye guys.